This question deals with trigonometric identities, and what we have to show is that the left hand side is identical to the right hand side. So left hand side is cos squared x minus sin squared x divided by 1 minus sin squared x. Remember, we have this identity sin squared theta plus cos squared theta is identical to 1. From here, if we send the sin squared theta to the other side, we can have that cos squared theta is identical to 1 minus sin squared theta. So from here, what we can write is that cos squared x minus sin squared x divided by cos squared x, because 1 minus sin squared x is cos squared x. Now we can use the rule of simple fraction. We can use a minus b by c is equals to a by c minus b by c. Using that rule, what we can write is cos squared x divided by cos squared x minus sin squared x divided by cos squared x. So this cos squared x and cos squared x cancels and it turns out to be 1. And we have another rule of identity which turns out to be tan theta is identical to sin theta divided by cos theta. That means instead of writing sin theta by cos theta, we can write tan theta. Since there is a square, we can write tan squared x. So now we have proved a left hand side equal to right hand side. Therefore, left hand side is identical to right hand side. For this part, question B, we have to solve this equation. And one thing we can do is use the previous question. If you take a look carefully, this particular portion is the same as what we did previously, which is 1 minus tan squared x. So instead of writing this, we can write 1 minus tan squared x. So ultimately it would turn out to be question number B, 1 minus tan squared x plus 2 equals to 0. That means minus tan squared x equals to 1 plus 2 is 3. This would be minus 3. And the minus and minus cancels, and we can write tan squared x equals to 3. The next thing would be sending the square to the other side. Remember, tan squared x is the same as tan x whole squared. So if you send the square to the other side, it has to be tan x equals to plus minus square root of 3. Remember to write down the plus minus sign, otherwise you would only get half of the sum correct. So it would be plus minus square root of 3. So now we have two particular sums. One is for tan x equals to plus square root of 3, and the other one would be minus square root of 3. Now how to solve this question? So the rule goes like this. When you have an equation that has sin x equals to something, or cos x equal to something, or tan x equal to something, the first step that you have to do, step 1, is you have to select the quadrant. So step 1 is select the quadrant, and the quadrant is cos positive, all positive, sin positive, tan positive, CAST. Select the quadrant. So if we select the quadrant, it would be, so tan positive is in this quadrant, the third quadrant, and tan positive is also in A. That means everything is positive, all positive, also in the first quadrant. Now the next step would be the basic angle. So basic angle. The basic angle is, when you select the quadrant, we have selected this one and this one, you have to find the basic angle with the horizontal line over here. It is not with the vertical line, it's with the horizontal line. And the basic angle is always with the absolute value. That means if you have, for example, here tan theta equals to A, the basic value would be, absolute value of A is A, so this would be tan inverse of A. On the other hand, if it was tan theta equals to minus A, then it would be theta equals to absolute value of minus A is also A, so it would also be tan inverse of A. So that is the rule for basic angle. So the first basic angle, therefore, x equals to tan inverse of square root of 3, and tan inverse of square root of 3 turns out to be, if you think about this particular triangle, you can use the calculator, but if you think about this particular triangle where this is this is square root of 3, this length is 1, this is 2, then this is 30 degree, and this is 30 degree, and this is 60 degree. So if you think about this triangle, 30-60 triangle, so tan 60 degree is opposite by adjacent, which is root 3. So tan 60 degree is root 3, so the basic angle should be 60 degree. But if you pay attention, we have to do the sum in terms of pi. That means 60 degree is pi by 3. So let's put it over here. So this would be pi by 3, and this would be pi by 3. So we have done the second step. The third step is to find the actual angle, so that is finding the angles. To find the angle, this is the thing, if it's in the first quadrant and this is theta, then your angle, basic angle, if this is the basic angle, then your angle theta would be equal to the basic angle. On the third quadrant, if this is the basic angle, then the angle theta would be 180 degree plus basic angle. That is the rule. So what we can do here is we can write so the first quadrant is going to be the same, so x equals to pi by 3, same as the basic angle, and the second quadrant is going to be 180 plus the basic angle. 180 is pi plus pi by 3 turns out to be 3 ones are 3 plus 1, 4 pi by 3. So we did the first part, we got two angles, and then we have to do for the negative portion, tan x equals to minus square root of 3. So here the basic angle is going to be, if tan x is negative, it is going to be in sine quadrant where tan is negative, and the cosine quadrant, so second quadrant and fourth quadrant. So here what we are going to have is, this is going to be one of the quadrant and this is going to be one of the quadrants. So let's find the basic angle. So remember, the basic angle is going to be the absolute value. Therefore, so x equals to tan inverse of absolute value of minus square root of 3 is square root of 3, and again from this triangle square root of 3 turns out to be pi by 3. So let me put it over here. This is going to be pi by 3, and again this also is going to be pi by 3. So what we have to do is select it. So step 3, what we have, if in the second quadrant, so if the basic angle is this, then the theta would be 180 minus basic angle, and in the fourth quadrant, if the basic angle is this, then theta would be equals to 360 minus basic angle. So that is the idea. So what we can do is we can write x equals to, so 180 minus basic angle, since it is in radian, pi minus pi by 3, and this turns out to be 2 pi by 3, and then x equals to 360 minus basic angle in the fourth quadrant, so this angle, so it would be 2 pi minus pi by 3, this would be 5 pi by 3. So now we have to write down the answer, since the range is from 0 to 2 pi, so the range would be, answers would be x equals to pi by 3, then we have 2 pi by 3, then we have 4 pi by 3, and then we have 5 pi by 3. I'm arranging from smallest to largest. In question number 7, what we have to find is, we have to find f1, but they have not given us fx, they have given us f prime x. That means they have given us dy by dx. F prime x is the derivative of fx, the same as the derivative of y is dy by dx. So in order to do this, we have to have an expression of fx. Now this is known as the fundamental rule of calculus, which says integration is the opposite of differentiation. So if you take d by dx of fx, you get f prime x. That means if you now take integration of f prime x dx, you would get fx, and of course there would be a plus c. So that is the idea behind it. So first of all, in order to find f1, we need fx. So the first thing we have to do is write fx equals to integration of f prime x, which is 4 x to the power minus 3, bringing x cube upstairs, plus twice x minus 1 dx. This turns out to be 4, so this would be x to the power minus 3 plus 1. Remember the basic rule of integration. The basic rule of integration states that if you have to integrate x to the power n dx, it would be x to the power n plus 1 divided by n plus 1, and there would be a plus c because it's indefinite integral. And if you have to integrate a constant, for example, integration of a would be ax plus c. So that's how it goes. So what we have to do is minus 3 plus 1 is minus 2 divided by that minus 2 plus 2 is the constant. So x, when you integrate this, the power will increase by 1. So this would be x squared divided by 2 minus, if you integrate the constant 1, it would be 1x, meaning x. And since it's indefinite integral, there would be a plus c. So we are almost there. So 4 divided by minus 2 is minus 2, and x to the power minus 2, if you bring it downstairs, would be x squared plus this 2 and this 2 cancelled. This would be x squared minus x plus c. Now in order to find fx, we need to find the value of c. So one information is given. It is given that it passes through the point 2, 3. That means when x equals to 2, y equals to 3. So when x equals to 2, y equals to 3, that means f2 equals to 3. So let's put the value. So 3 equals to minus 2 by 2 squared, putting the values of x, plus 2 squared minus 2 plus c. That turns out to be 3 minus equals to minus 2 by 2 square is half, plus 4 minus 2 plus c. That turns out to be 3 plus half, and 4 minus 2 is 2. If we send the 2 to the other side, it will be minus 2 equals to c. Therefore c equals to 3 minus 2 is 1, 1 plus half is 3 by 2. So c equals to 3 by 2. That means we can write fx equals to minus 2 by x squared plus x squared minus x plus 3 by 2. This is fx. Since we know fx, the main question is find f1. So f1 would be equals to minus 2 by 1 square plus 1 square minus 1 plus 3 by 2. So minus 2 by 1 square is minus 2, plus 1 minus 1 cancels off, and we have plus 3 by 2. Now 3 by 2 you know is 1.5. So 1.5 minus 2 is minus 0.5, which is minus half. Question number 2 is not related to the first part. It belongs to the same topic, the topic of integral calculus. This one is definite integral. That means it has a limit. We don't have to do plus c. So in question number 2, what we have is we have the value of the definite integral. So what I'm going to do, I'm going to integrate this. So 1 to 4, 3 x to the power half, square root means to the power half, plus a, we don't know what a is, but we only know it's a constant, dx equals to 21. So let's integrate this, the left hand side. So 3 is the constant, x to the power half, if you integrate it, the power would be increased by 1. So half plus 1 is 3 by 2 divided by 3 by 2 plus, when you integrate a constant, it is just the constant times x. And the limit is from 1 to 4 equals to 21. So the first thing we have to put is we have to put the value of 4. But before that, let me simplify it a little bit. 3 divided by 3 by 2 is 3 times 2 by 3, which is 2. So 2x to the power 3 by 2 plus ax, and we have the limit 1 to 4 equals to 21. So let's put the value of 4. So 4 is going to be 2. 4 to the power 3 by 2 plus a times 4 minus, if we put 1, it would be 2. 1 to the power 3 by 2 plus a times 1, and this is equals to 21. So if we simplify this, it would be 2 times, now 4 is 2 square, so that means 2 square into 3 by 2. Remember the rule of indices. This is, if you have x to the power a to the power b is x to the power a into b. So that's the rule of indices. So the exponents are multiplied together. So this would be 4a. Now minus 1 to the power anything is 1. So 2 into 1 to the power 3 by 2 is just 2. And minus, this is going to be a equals to 21. So this 2 and this 2 cancels off, and let me write it over here. So this is going to be 2 cubed. 2 cubed is 8. So we have 2 times 8 plus, now 4a minus a is plus thrice a, and we have minus 2 equals to 21. So 2 into 8 is 16. 16 minus 2 is 14. 14 plus thrice a equals to 21. Now we have a simple linear equation which we can solve. So thrice a equals to 21 minus 14, which is going to be 7. Therefore a equals to 7 by 3.